Okay, so with 35, we said, how many divisors did we have?
We had 4 divisors.
4 divisors. 1 and 35.
And then 5 and 7.
5 and 7. So we had a total of 4 divisors.
Yeah.
And for, what did we just do, 50?
Yeah.
I should have left 72 on the board, but 1 and 50, 5 and 10. Oh, sorry. And how about 2 and 25 first? My fault. 2 and 25, and then 5 and 10, so there were 6.
Yep.
So it's interesting to try to figure out how many divisors there are, and I guess for 36, we had 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6. So we actually had 2, 4, 6, 8, 9 divisors for 36.
So, I see a way to do this.
Okay.
Well, to find the number of divisors, you have to factor your number.
Okay. So,
Into primes.
Yeah.
okay, how does 35 factor into primes?
35 is 7 times 5.
Alright, I'll write it
5 to the
5
1.
times 7, 5 to the 1 times 7 to the 1. What about 50? How does that factor into primes?
50 factors 2 to the 1 times 5 squared.
2 to the 1 times 5 squared. And how about 36? How does that factor?
36 factors 6 is 2 squared times 3 squared.
Alright, 2 squared times 3 squared. Okay.
Well, to do this, for the number of divisors, for 35, you can have 0, 5, or 1, 5. So you have 2 choices for the 5.
Okay, I can either have no 5s or 1 5.
And
Alright.
then the same for the 7. You can have 0, 7s or 1, 7.
Alright.
So that makes 2 choices for each, and if you multiply them today, you get 4.
Okay, so I can either have 0 or 1 5s. I can make a chart like this. 5s, 0 or 1. 7s, same thing. 0 or 1. And if I have no 5s and no 7s, in other words, 5 to the 0 and 7 to the 0, what do I get?
You have 1.
1. If I have no 5s, 5 to the 0 power and 1 7 times 7 to the 1, what do I get?
You have 7.
1 5 and no 7s?
5.
1 5, 1 7?
35.
35. So there you go. There's our divisors, and that's how we got 4 of them. Now, can you show me how do I find the number of divisors of 50?
Well, here you have 0 or 1 choices.
Yeah, for the 2.
Yeah.
So I have 2 choices for the 2.
And then you have times 0, you have 0, 1, and 2 choices.
So
That's
times
5.
3.
So I have 3 choices for how many number of 5s I can have. 0, 1, or 2. So 2 times 3 is
It's
6.
6. Similarly for this one, I have 3 possible choices for the
Yeah.
2. 0 2s, 1 2 or 2 2s. And 0 3s, 1 3 or 2 3. So I have 3 times 3. Which is
9.
9.
Cool.
Oh, I hope I'm not off the board here. But so it turns out that summing the divisors requires us to find the divisors.
Yeah.
Taking the product of divisors, actually, we found you came up with a very cool formula about the number of rows and whatnot. And it was the number to that power. So if we just knew how many divisors there were, we could divide by 2, and that would be the number of rows,
Yeah.
unless it's a perfect square. So we could actually find the product without knowing what all the divisors are, but we couldn't find the sum without knowing what all the divisors are. So that's interesting, right?
Yeah.
Maybe there is a way to find the sum without knowing what all the divisors are. Wouldn't that be cool?
Yeah.
Yeah.
But I don't know. Actually, I don't know if there is or there isn't. I just don't know. Factoring it into primes helps you see the products, why the products work.
Yeah.
But when you factor into primes and then you add, like, even if you just had a simple number like 35, you don't have a number when you add them together that's divisible by the numbers anymore. Okay, like, what was the sum? Was 48, right?
Yeah.
48. It's not divisible by 5 or 7, so hard to know. Anyway, it's pretty neat, right?
Yeah.
Do you like numbers? Do you like this basic number theory?
Yeah.
Do you like it? Do you have any other questions you think might be fun to talk about with divisors?
Not really.
Don't worry, we're not going to talk about them. What would be one other question you might have?
Maybe if we did the number of if we took two numbers and found the number of divisors and multiplied them together.
Okay. Maybe we could look at it for pairs of numbers. That'd be fun.
Yeah.
Or the sum of the positive divisors in different bases.
No, maybe looking at different bases is an interesting way to think about it. So maybe we'll have to check that out. Okay, cool. Good job, guys. Good job. I am glad to be home and doing some math with you guys.